Hi, I'm Alex. I'm an engineer on the Shazam team. Thanks for joining this session. Today, I'm going to show you how to create custom audio experiences for your app with ShazamKit using custom catalog recognition. On this session, I'm going to use some of the existing ShazamKit concepts, such as catalogs, signatures, and media items. If you're not already familiar with those, make sure to check out the Explore ShazamKit talk. Let's take a look at what we will be covering today. We will talk about how to build catalogs with custom audio and metadata. We will learn how you can match audio to your own custom catalog when using the microphone and the AVF audio framework to record audio. Then we are going to customize our app to synchronize content to the custom audio. Finally, we will cover some of the best practices that you can use when working with custom catalogs. This is a code-along. There is a project available on the developer portal that we will be using throughout this session. I recommend that you download the project before we begin. As learning becomes increasingly more digital, we need to come up with ways to keep children engaged. What if you could play a video on your Apple TV and have a companion app that displays questions at exactly the right time? Today, I'm going to show you how to build a remote app that synchronizes and reacts to an educational video using custom catalog recognition. First, what are custom catalogs exactly, and how do we build one? Custom catalog is a collection of signatures that you generate from any audio. You can also add associated metadata for each signature. To add signatures to your custom catalog, you can use the signature generator object. It will convert audio buffers into a signature. First, create a signature generator, then, using the install tab function on the audio engine's input node, append the buffer and the audio time to the generator. The buffer parameter is a buffer of audio captured from the output of the input node. Audio time is the time when the buffer was captured. When you specify the audio format, make sure that the format is PCM in one of the supported sample rates. Calling the signature function on the generator will convert the audio buffers into a signature. We call this the reference signature, which we can then add to a custom catalog. You can also add signatures to a catalog by using a Shazam signature file. This is an opaque file that can be shared across devices. To make it easier adopting custom catalogs with ShazamKit, for this session we included this file for you to use. Before we begin, let's open the downloaded project and see what we have in there. Let's take a close look at the question object. A question represents a custom content in the app. First, there is a title and an offset. A title is a string describing a section in the video. Offset is the time when this section appears. For example, at 45 seconds, the teacher starts talking about a math equation. You would create a question with that title and 45 as the offset. Equation represents a teaching moment showing mathematical equations. You can use this as incremental building blocks. For instance, you might want to show the left and the right-hand side of an equation at different offsets. Finally, answer range and requires answer are used to indicate when an interactive UI would show, so children can practice answering the questions. Let's take a look at what this would look like for our educational video. The first question starts at 14 seconds. I have 1 red apple at 21 seconds, and adding 3 green apples at 25 seconds. Finally, at 31 seconds, the student will have a chance to answer the question. Note that videos are usually formatted in hours, minutes, and seconds, so to create offsets like I did here, you should convert the time into seconds first. For example, you could ask Siri for help, like, what's 3 minutes and 14 seconds in seconds? Now, let's dive into the code and see how we can get started with custom catalogs. First, I'm going to build a catalog by adding a signature with some metadata associated to it. Here, I have catalog provider with a function that creates the catalog. The reference signature that you are going to add to the catalog is called foodmath.shazamSignature. Let's load that file in and create a signature object from it. Once you have that, you define the metadata using media items. I'm going to set some of the predefined media item property keys, such as title and subtitle. This is going to describe the educational video. I also created an extension on shMediaItem property with two custom keys, teacher and episode. Setting the episode number and the name of the teacher will further customize the content of the catalog. All you have to do now is to create a custom catalog object. Then call addReferenceSignature on it and pass in the signature and the media item object. This will associate the metadata you just created with the reference signature you loaded from disk. Perfect. Now that I have that in place, I can start matching audio to the catalog and see the result in action. So let's open the matcher. We are going to match the input audio from the microphone to the content of the custom catalog we just created. To capture audio from the microphone, you can use AV Audio Engine from AVF Audio. In this project, I already added a description for the microphone usage in the info.plist file. Also, in the matcher, I included code to request microphone permission and set up the audio session. First, to receive updates on matches, you create a session object and set the delegate. The match function takes the custom catalog we created before, so you can just pass that to the session. Now, you're ready to match the audio using the install tab function on the audio engine's input node. The function returns an audio buffer, which is the converted audio from the microphone, and an audio time, which is the time when the buffer was captured. Then, you call matchStreamingBuffer on the session and pass in the audio buffer and the audio time. We recommend that you include the time when available, as this is going to be validated by the session to ensure that the provided audio is contiguous. Since you set the session delegate at the beginning, to handle updates, you can implement the session.didFindMatch function from the session delegate. For this, I created an object called matchResult. It contains a matched media item returned by the session.didFindMatch function. This is the metadata that's associated with the reference signature in the catalog. It will include details we created earlier, like the episode number and the teacher's name. It can only be generated from a match, and it contains extra information related to that. Also, in the match result, we have the question object I showed you earlier. This is representing a section in the video with a math equation. We will use this to find the relevant content for a match. So inside the delegate, we set matchResult to take the first matched media item object, and for now we will set nothing for the question. Now, let's build and run and see the match in action. This is our FoodMath app. It has a list of episodes that are available for the students. I can play the video, and together with my colleague Neil, we can learn to solve some math problems. Neil, what do you have for us today?
So the format is, I'll ask you a question, you'll have some time to think about it, and then we'll see if you got it right. You can play along too if you have our app.
As I started the video, the app recognized that we are listening to episode 3, Count on Me. This is great. Next, I want to figure out what sections to show for a particular offset in the audio using our question object. We use matched media item to know what video we are watching, but it also contains extra information about a match, such as the predicted current match offset. This is an auto-updating position in the reference signature, represented as a time interval in seconds. You can use this to figure out where you are in the video and find the relevant question object. Going back to the code, in the delegate callback, instead of setting nil, I want to find the last question that comes right after the predicted current match offset. I can use the question's offset to compare the values. Session did find match can be called multiple times with the same match. So let's implement a filter that will only update the result when you get a new question object. Once you have that, you can update the result with the value. Now, let's see how that looks. Build and run. This time, I want to learn about addition. I'm going to play the video again and see if the content of the question will show up sync with the video.
Question 1, let's get started. I went to the shops today and I fancied some apples, so I bought 1 red apple and I bought 1, 2, 3 green apples. How many apples did I buy in total? Your timer starts now.
Now it's question time. What's 1 plus 3? Could it be 5? Oh, no, I got that one wrong. Let's try again. I'm going to rewind the video, and this time I'll pay more attention.
Question 1, let's get started. I went to the shops today and I fancied some apples, so I bought 1 red apple and I bought 1, 2, 3 green apples. How many apples did I buy in total? Your timer starts now.
Now that I heard that again, I know that the answer is 4. What if you find this question too easy? Let me skip forward and see if Neil has something a bit more complicated to teach us.
Question 4, the last question. So today I'm feeling pretty hungry, so I've decided I'm going to buy 14 apples. 1, 2, 3, 4.
That's a lot of apples. Let me go ahead a bit more. Skip ahead 20 seconds.
So I decided to buy another 28 apples. One, 2, 3, 4, 5, 6, 26, 27, 28 apples. How many apples did I buy in total? Your timer starts now.
Now that is a great question. Did you follow? I'm going to go with my favorite number. That is correct. The answer to the ultimate question is 42. It's simple. No matter where the student is in the video, your remote app will keep up and update the content. Let's cover some of the best practices when using custom catalogs. Custom catalogs can be shared between devices seamlessly using the Shazam catalog file extension. You can load from and save to disk using a file URL, as well as deliver them over the network. When using a remote web service, you may want to download the catalog first and then use the add function on the custom catalog object. Make sure to provide a local catalog when there is no available one over the network. Catalogs can store custom keys to return data specific to your use case. make sure that the data you add in your catalog is one of the valid property list values. When using Match Streaming Buffer, ShazamKit will match the audio stream and balance the performance as well as the intensity of the search, doing all the work of generating and auto-updating the signature for you. So now you build a full app that's synchronized to an educational video, updating the content to where the student currently is, using only a signature and the custom catalog. This is just one of the many examples that is possible, and we are really excited to see what you will build using ShazamKit. Thank you, and have a great WWDC.